Welcome to this online presentation. I am Alexandre Celma Miralles from the Center for Music in the Brain, and I will present a couple of studies dealing with the discrimination of the musical features of a tune by rats. These studies were run together with Paola Crespo Bojorque and Juan Toro from the Language and Comparative Cognition group. The goal of these studies is to discover which musical features of a tune can be discriminated by rats, a mammal distantly related to humans. Our aim is to explore the biological basis of core musical features, focusing on pitch, tempo, and rhythm in Study 1, and in rhythmic and melodic organization in Study 2. Our previous work demonstrated that rats are sensitive to musical traits as rhythm and harmony. For instance, rats are able to discriminate isochronous sounds from jittered sounds at distinct tempi, as well as consonant chords from dissonant chords. To study rats, we use sun-attenuated Skinner boxes equipped with a speaker, a pellet feeder, and an infrared detector located in the pellet feeder to register nose-poking responses. That is, we count how many times rats look for food in the feeder after listening to each stimulus. In these studies, we used a familiarization paradigm. 32 rats were familiarized with an excerpt of the Happy Birthday song. During the familiarization sessions, the Happy Birthday song was presented many times, followed by a time period in which the rat could poke the feeder with the nose and get full reward. After the familiarization sessions, two stimuli were presented, intermixed with the familiar stimulus, but without giving any full reward. These test sessions allowed us to compare the behavioral responses between familiar and unfamiliar stimuli. Our familiar stimulus was the Happy Birthday song, played on a piano at 140 beats per minute. We created pairs of novel stimuli by manipulating three musical features: the pitch, high octave or low octave, the tempo, double or half speed, and the timbre, a violin or a piccolo flute. We obtained a smaller number of responses to the unfamiliar timbre manipulated stimuli than to the familiar tune. In contrast, we recorded a number of responses similar to the familiar tune for the pitch manipulated and the tempo manipulated stimuli. We found no differences between each pair of unfamiliar stimuli. This first study shows that rats react differently when the melody changes in timbre, but not when it changes in octave or speed. It is an open question whether rats may have identified the familiar melody across tempo and octave, or just noticed that the spectral envelope was the same, a piano timbre. Timbre is clearly a silent feature for rats, but what would happen to the rhythmic and melodic organization of the tune if the timbre doesn't change? In a second study, we created two novel and familiar stimuli to answer this question. One maintained the rhythmic organization and reduced the melody to one tone. The other maintained the melodic intervals and scrambled the rhythm. In this study, we found a novelty effect in rat responses. They gave more responses to the rhythmically scrambled stimuli than to the isotonic and the familiar ones, while they didn't discriminate the familiar tune from the isotonic rhythm. Thus, rats' discrimination may be based on the underlying rhythmic organization of the tune. However, if we divide the rats into three groups, depending on how many responses they gave to one or the other unfamiliar stimulus, we can see that there are 2 rats that didn't discriminate among the stimuli, while there are 8 rats that have given more responses to the isotonic rhythm than to the rhythmically scrambled and the familiar tune. This may mean that a subgroup of rats may have paid attention to the absence of melodic intervals, rather than to the rhythmic organization of a tune. This second study shows that most rats detected the manipulation of the temporal organization of simple ratio durations, if not all the sequence, at least part of it. Moreover, it also shows that some rats detected the manipulation of the melodic organization, responding differently to the constant pitch stimulus. Again, it's an open question whether they paid attention to all the melodic intervals or just the presence of one pitch. In sum, these two studies show that rats have the cognitive abilities necessary to discriminate the spectral envelope of distinct musical instruments, timbre, and the organization of the temporal events of a melody, rhythmic organization. Therefore, These musicality traits could have evolved across the species from the processing of relevant sensory information of sounding objects in the environment. To end up, I would like to thank you for your attention and acknowledge the institutional funding that supported this research, the organizers of this conference, and all the rats that were tested.